The upcoming NE1 detector, which will be constructed at the Advanced Instrumentation Testbed at the Bolby Mine in the UK, will be an optical neutrino detector, cylindrical in shape, that will demonstrate reactor monitoring by detecting anti-neutrino interactions in the bulk of that cylindrical volume. And in fact, the dominant background to the reactor measurement comes from the decays of trace radioactive isotopes found in the photodetectors themselves, which reside on the surface of that cylindrical volume. So there are gains to be made in signal sensitivity if you have improvements in position reconstruction, and in fact it's been demonstrated in this sort of plot I cite here that there are gains to be made in position reconstruction if you have improvements in the timing of your photodetectors. Okay? So one option for improved timing is the so-called large area picosecond photodetector, or a device known as an LAPPD, produced by Incom, a company out of Massachusetts. And this device boasts timing resolutions on the order of 50 picoseconds, quite impressive, over, of course, large sensitive areas approaching almost 400 square centimeters. So one of these devices was purchased by Sandia National Labs back in the summer of 2019 to conduct an independent, objective quantification of the performance specs of these devices. And after that study was complete, we were lucky enough at Berkeley to get this, which is called tile number 22, on loan to actually start using it in sort of real applications, right? Demonstrate the utility of the improved timing. So one of the things we did is measure the time profiles of liquid scintillators using the LAPPD. Okay, so the setup here is we've got the tile, and I show photos over here. We mask off the entire face, right? And on top of that mask, we put a small cuvette filled with whatever scintillator we're interested in, coupled to a PMT, which we use to trigger the system. And as a source, we use sodium-22, which emits a 1.2 MeV gamma, and also a positron, which annihilates in short order into two 511s. So in fact, it's a multi-gamma source, 3 gammas. So first, we take data just, as I say, with the entire LAPPD masked off. The cuvette is filled with LAB. This is a mineral oil-based scintillator with a relatively slow scintillation time. And so what happens is one of the source gammas, interacts in the LAB, produces Cherenkov light, which the PMT sees and triggers the system. And another gamma from the source penetrates the mask and interacts with the LAPPD itself, typically in the glass above the photocathode, again creating Cherenkov light, which is observed by the LAPPD. This provides a prompt signal to both the PMT and the LAPPD, from which we can calibrate the effective TTS of the system to about 140 picoseconds, which lines up pretty well with the expectations from device specifications. Then we open up a small hole in the mask underneath the cuvette, making the LAPPD sensitive to photons produced in the scintillator. The hole has to be small to ensure single photon regime. And triggering the setup in much the same way, we then measure the time profiles of whatever scintillator we're interested in. So here in this bottom row I show the sort of observed timing for 2 water-based liquid scintillator samples. On the left, a 1% formulation, and on the right, a 10%. And already, without getting into the numbers, you can see the benefit of having this improved timing, right? Particularly in the peak, where there is both scintillation light present and also the Cherenkov light from the sample and from this this background of interactions with the LAPPD glass. Okay, but you can see the 1% with less scintillator is notably peakier than on the right hand side. Okay, so very, very cool stuff. It's a cool kind of confirmation of the precision timing resolution and demonstration of how it affects real measurements. This was all done with tile number 22, which is out of our hands now, but I'm happy to say that our group actually just purchased our own tile number 93 from Incom. Okay, so if you stop by the poster, I'd be happy to talk to you more about these measurements and the really exciting plans we have for the new tile. I show that here kind of fresh out of the box. So thanks.